Today we're going to extend what we've talked about with graphing sine and cosine, and I want to come back to one of our problems from yesterday and let's graph it. All right? Let's actually start graphing some of these so that you get a feel for the process that we need to go through. Let's say that I wanted to graph y equals sine of 4x. Let's just start with a pretty basic graphing problem. Okay? Well, like I told you yesterday, we find the period, all right? Remember that for a normal sine function, if I have just y equals sine of x, we said yesterday that its period is 2 pi. That's how long it takes to do one period of the sine function. But if I have a number in front of the x, then we need to use the little formula that the period is 2 pi divided by b. And b is this number in front of x. So let's find out what the period is. The period is 2 pi divided by 4. And we can simplify that little fraction and find out that the period is pi halves. Now, this is where I want to introduce something very important, and it is the concept of what I call road markers. And we will usually abbreviate these as RM. What do we mean by road markers? Well, these are the quadrantal values that I talked about yesterday. We're always going to break this thing down into fourths. Okay? So to find the road markers are found by multiplying, we're going to multiply the period by 1/4, then count. Well, we'll just say then count up. And I'll show you how this works. It's very easy. Once you do one of these, it's actually a pretty simple process. All right? So what was my period? My period was pi halves. I'm going to come back to blue here. My period was pi halves. So to find my road markers, notice I'm labeling them RM for road markers, I'm going to take that pi halves and multiply it by 1/4. So when I multiply pi halves by 1/4, don't I get pi eighths? All right. So my road markers are pi eighths. Let me show you how this works on the graph now. It's very easy. We're going to sketch our graph, and we always come over here and we put my period at the far right. What was my period for this one? Wasn't it pi halves? Right? So we're going to put my period over here. And I know that the sine function is going to do one period between 0 and pi halves. All right? But yesterday when I sketched this for you, I told you that we break this up into 4 quadrantal values. Okay? And this is where my road markers are going to go. Didn't we just say that my road marker was pi eighths? So watch how this works. It's very easy. I'll use a pretty color here. My first road marker is pi eighths. And I told you to count up. So this is 1 pi eighth. You don't have to put the 1 in there, but just bear with me. That's 1 pi eighths. Then this will be 2 pi eighths. Then this will be 3 pi eighths. And the last one will always work out to be your period. Isn't 4 pi eighths the same thing as pi halves? Isn't that neat, the way that works out? And guess what? We're done. The hard part is over. By the way, what was the amplitude of this one? We learned that yesterday. If there's nothing there, it's just 1, isn't it? So the amplitude of this thing is 1. 1, negative 1. And now all I need to do is use those same corner values that I taught you, the sine of 0, 0. At the first quadrant value, it's 1, back to 0, back to negative 1, back to 0. And there is 1 period of the sine graph. And it's not near as hard as what you thought it was. Now, what if they wanted 2 periods of the sine graph? What would I do? Well, remember, it repeats, doesn't it? It's periodic. So we're not going to do this on every problem, but you do need to know how to do this. If I wanted to do 2 periods, then there's the first period at pi halves. Okay? So what's pi halves plus pi halves? It's 1 pi. So here's the first period. Okay? Over here is the second period. Now you just found out the road markers, right? Pi eighths. We said those were pi eighths, 2 pi eighths, 3 pi eighths. This one was like 4 pi eighths, right? So guess what? All you have to do is keep counting. 4 pi eighths, what's the next one after that? 5 pi eighths, 6 pi eighths, 7 pi eighths, and what's 8 pi eighths? Isn't that 1? It always works out. And so guess what? Everything's the same. You still follow your corner values, 0, 1, 0, negative 1, 0. And guess what? You just keep going. 1, 0, negative 1, 0. And now I have 2 periods of the sine graph. All right? And the only other thing that we could do to clean up our graphs, both this one and the first one we did, is couldn't I reduce some of these fractions? Look at this 2 pi eighths. What's another way I could write that? That would be like pi fourths, wouldn't it? And this, let's see, 6 pi eighths. That would be like 3 pi fourths, wouldn't it? And to me, that's kind of a detail that, you know, if you get all of this right and you forget to reduce one of those road markers, I'm not going to be real upset because you've done 99% of the problem correct. Let's do another example. What if I wanted to graph y equals 2 cosine of 3x? We haven't done a cosine graph yet, so we need to do one of these. Our process is still the same. We're going to find the period first. Okay, this one we can move through a little bit quicker. Period is always going to be 2 pi divided by the b value. So what's the b value? 3. All right, so there's my period. Next thing you want to do is find your road markers. So let's find the road markers. The road markers are going to be the period times 1/4. So I do my factoring. 2 divided by 2 is 1. 4 divided by 2 is 2. So my road markers are going to be pi sixths when I simplify that fraction. So we start the same way. I'm going to put my period out here at the end. My period was 2 pi thirds, so I'm going to have a 2 pi thirds out at the end. And then I break it up into my quadrants. We'll just sketch one period of this for now. And I start counting up by my road markers. My road markers are pi sixths. So 1 pi sixth, 2 pi sixths, 3 pi sixths, 4 pi sixths is the same thing as 2 pi thirds. So we don't even have to write that one again. And now notice, what was the amplitude of this one? 2. So I need to make this go up to 2 and down to -2 for my amplitude. Once you have your amplitude and your road markers in place, we just put in my dots. And yesterday, remember the corner values for cosine, it starts, instead of starting at 0, it starts at 1, right? Well, if it's the amplitude is 2, then instead of starting at 1, we start at 2. And then everything else just follows through the same. 2, 0, -2, 0, +2. And then we just connect the dots. Now you might be saying, well, that doesn't look like a sine graph. Well, it would if I kept it going this way, right? Remember that cosine is pi halves behind, all right? Now in this case, that'd be a little bit different because the period is different, but it is always one road marker behind. So this one would be, I could keep sketching over here to -pi sixth if I wanted it to look like a cosine graph, but we don't need to worry about that. What we've got here between 0 and 2 pi thirds is one period of cosine, and that's totally acceptable. All right? Now, let me show you a little quick thing that I don't want to go through a whole other example for. What if the amplitude is negative? I know this is going to make this graph ugly, but that's okay. What if this would have been a -2? The only thing that would change is instead of starting up here at +2, I would start at -2. And then I'd follow my same process. So I would start here, and then I'd go to here, up to here, here, and back down to there. So it's basically reflected. This would be the graph of -2 cosine of 3x. So if there's a negative out in front, you just start down here at -2 and go up through. All right? We're doing very well. And I want to give you one to kind of try on your own now. So let's try this one as our last problem. Why don't you graph y equals 3 sine of x over 2? And I will pause the video. Okay, let's see how you did. On this one, your period, this x over 2, remember, is like 1/2 x. So this is my b. Period equals 2 pi divided by 1/2. So that's 2 pi over 1 times 2 over 1, which is 4 pi. So your road markers are 4 pi times 1/4, which means your road markers are pi. So your period is 4 pi. Count up by 1 pi, 2 pi, 3 pi. And then your amplitude is 3. So you're going to come up to 3, down to -3, and then put in your points. And I think most of you did real well. And we will stop there for today.